Hello, and today's purpose of the day is I can multiply and divide rational expressions. The first thing that we will look at, which will help us with today's notes, is how do we multiply and divide fractions. So the following two is a multiplication and division case of fractions. Please take the time to jot these down in your notes to remind yourselves how you multiply and divide fractions. Just a little recap, I'll show my notes. So when I multiply 3/4 by 5/6, I would first look at simplifying any cross products. So I would take out a 3, change that to a 1, change a 6 to a 2. Nothing goes in the 5 and the 4, so we multiply straight across and get 5/8. And that would be my answer. Now when we divide fractions, really we flip the second and multiply. So 3/4 times 6/5. Look at crossing out cross products, and out of the 4 and 6 I can take out a 2. So if 4 becomes a 2, 6 becomes a 3, multiply straight across and get 9/10. 11.4, multiplying and dividing rational expressions. Our first goal is to multiply. So let's take a look here at number 1. I have 7x squared y over 12z cubed times 14z over 49xy to the fourth. Let's look at canceling out any cross products. So if the 7x squared y and the 49xy to the fourth, I can take a 7 out. That 7 becomes a 1. The 49 becomes a 7. If I take out an x down here, I'm left with just 1 up top. If I take away a y, I'm down to y cubed. And then if I look at the other cross products, 12z cubed and 14z, I can take a 2 out of both the 12 and the 14. So the 12 becomes a 6. 14 becomes a 7. If I take away that z there, I'm down to z squared. Now, I'm really just multiplying fractions, but now I have, different terms. I have variables and numbers, so I looked at simplifying cross products first, and now I'll multiply straight across. But before I multiply straight across, I also can cross out things if they are directly a numerator over a denominator, and they're directly the same thing. I can actually simplify that. So what I notice with the 1x over 6z squared, I really can't cancel anything, but then I look over at the second fraction and I have 7 over 7y cubed. Well, those 7s actually can cancel out as well. So now I can multiply straight across because I believe I've simplified everything that I can, and I get 1x times just 1, so that would be x, over 6z squared times y cubed is 6y cubed z squared. And again, it's best to write these in alphabetical order. So that would be my final answer, and I could look now and see if there's anything that I could still cancel out, but there's nothing there that's left to cancel out. All right, let's look at number 2. I have 3x over 16x squared times 8x squared over 3. So now I will look at canceling out cross products as well. So the 3 and the 3 cancel out. The 8 and the 16, I can change a 16 to a 2. X squared and x squared go away. So I have 1x times 1. So I just get x over 2 times 1, which is just 2. So my final answer is x over 2. Let's take a look at number 3. Okay, 3's got a little bit more going on. I see x plus 3 over x times 5 over x squared plus 7x plus 12. So I actually need to factor that denominator in the second fraction. So factors of 12, that would add it together give me 7, are 4 and 3. So I really here have x plus 3 over x times 5 over x plus 3 times x plus 4. And now let's look at cross products. So the x plus 3 and the x plus 3 cancels out. And it looks like there's nothing else that can. So I have 1 times 5, which is 5, over x times x plus 4. And I can go ahead and leave my answer as x times x plus 4 because that's its simplified version. If I wanted to say x squared plus 4x, I also could do that. So that would be my final answer. All right, continuing on with 11.4, multiplying and dividing rational expressions, we will now look at our second goal, which is dividing. So let's take a look at number 1. Now, if you can recall, when we were practicing multiplying and dividing fractions, really when we divide fractions, we're just flipping the second fraction and multiplying, and the same process occurs as what we did then on the last slide. So if I flip the second fraction and multiply, I now have 15y squared over 4x times 8x cubed over 5y. And now I look at canceling out cross products. So I say here 15y squared and 5y, take out a 5 and get a 3 and a 1 down below. Take out a y and get just one y up top. Now if I look at the 4x and 8x cubed, 4 changes to a 1, 8 changes to a 2. If I take away an x, I'm left with x squared. Now I could look at if there's anything still left over needing to simplify, and I don't believe there is. So I have 3y times 2x squared. So that would be 6x squared y over 1 times 1. So I would have 6x squared y over 1, and I don't need the over 1. So my final answer would be 6x squared times y. Okay, let's look at number 2. I have 3x plus 9 over x squared divided by x plus 3. What do you think we should do here? Well, let's put the x plus 3 over 1 so that it looks like a fraction, and then when I have, when I'm dividing fractions, I really just flip the second fraction and multiply. So what this really turns into is 3x plus 9 over x squared, and then times 1 over x plus 3, because again, I flipped that second fraction. And now I look at canceling out, or looking at cross products and canceling out terms that are alike. So let's take a look here at the numerator of 3x plus 9, which might help us out if we simplify that. So what that turns into is I can factor out a 3 and get x plus 3 over x squared, and then still multiplying by 1 over x plus 3. Okay, so I can simplify the x plus 3 over x plus 3, and that appears to be the only thing that can simplify. So now if I multiply straight across, I get 3 times 1, which is 3 over x squared, and that would be my final answer. Okay, let's look at one final example. One little side note here that I have written down is, remember, only factors can be canceled, not individual terms. So, for example, if I had an x plus 3 over an x, could I simplify the x's there? No, I could not, because this x plus 3 is an entire term, and I could not just take out part of that. And what about if I had x plus 3 over 3? Couldn't I then simplify the 3's? No, I could not, because again, this is an entire term, which I can't just take out part of it without taking out the entire thing. It's a binomial. It goes together, or both terms go together, I should say. All right, let's look at number 3 here. X minus 5 over x squared minus 9x plus 18 divided by x squared minus 25 over x minus 6. Now, first, let's make this simpler, and let's flip the second fraction and multiply. So x minus 5 over x squared minus 9x plus 18 times x minus 6 over x squared minus 25. And let's look at factoring here. So I need to figure out factors of 18 that when added together give me negative 9 is negative 6 and negative 3. So what I actually have now here with this first fraction is x minus 5 over x minus 6 times x minus 3. Now that's multiplying by x minus 6 over, and then x squared minus 25 is a difference of 2 squares. So what that factors to be is x minus 5 times x plus 5. And now I look at canceling out any cross products, x minus 6 and x minus 6, x minus 5 and x minus 5. So what I end up having is, 1 times 1 over x minus 3 times x plus 5. Now I do need that 1 in the numerator of my fraction, because if I didn't have that there, then I wouldn't have anything in the top part of my fraction, and maybe forgotten that this actually was 1 over x minus 3 times x plus 5, because x minus 3 times x plus 5 over 1 is something that's entirely different. So this would be my final answer. Thanks for listening. Please check Google Classroom for more information. Have a great day. Bye.